What's going on YouTube, and welcome back to another C++ programming tutorial. I have all the code from our last one fired up, and let's just jump right into it. Today I was planning on teaching you about variables. So to start off, what I'm going to do is I'm going to create a variable. Let's call it a number equals 12. I'll explain how this works in the future, but let's say we take this out and we put number in that. Now, just take a moment and consider what's going to happen when I click run on this. How is it going to translate this value into that? And as you probably guessed, the number 12 will be printed out onto the screen. And let's see if I'm right. And I am. There you go. The number 12 printed out, as you'd expect. So I think there's a bit more to this than I'm really letting on. I'm just like, alright, so you're gonna just write these things down, then you're gonna set it equal to something, and then you're gonna print it out onto the screen. Yeah, that's part of it, but it's not the whole story. So I'll start off by teaching you the syntax for a variable, and it was exactly as followed, but I'll teach you why it's the syntax and why it works. Whenever you specify a variable in C++, you're gonna specify a type. There's so many different types. Let me create some comments here so I can, whoops, there we go. I'll start with what I just did. You have integer. This is basically a whole number value, and you can have floats, a single precision floating point value. You can have doubles, a double precision floating point value. You can have Booleans, either true or false. 1 or 0, really. And you have longs. This is our 60, I think, yeah, they're 64-bit whole numbers. And then you have longs, even more values, or even more possible values. And we can actually not even worry about this right now. I'll completely take this out, and then you have short. These are 16-bit values, and this is actually processor dependent. So what I'm saying here about how many bits a long is and how many bits a short is, that will actually depend entirely on your processor. I'm just saying what the standard is. A short is standard 16 bits, a long is standard that, and actually, as you might have guessed, an int's a 32-bit whole number. And then you have other types. These are not standard and just built into C++. Well, this one is. This is basically anything that has, it's surrounded by little brackets like this. They're basically letter values, usually encoded in ASCII, if anyone knows what that is. Alright, so these are the main types that you're going to be using. There are more, but these are really what you're going to be using when you create a variable in C++, for the most part. Of course, not all the time. But if there's anything else that's needed, it'll be very rare. So anyways, now that I've told you the types of variables, we can start by creating these. And like I said at first, specify the type, and I can always do float. And notice how they're all blue. All these will be encoded in blue because the compiler will recognize these as a keyword in its interface. Well, in its syntax. And even char, that's still a keyword. And then short. So we're gonna make an int. Int followed by the name of the variable. Variable name. This can literally be anything you want it to be, with a few restrictions. You can't do this because it'll actually, this character is not a valid character to be appended onto a string. You can't do this. Basically, you can't add special symbols to the variables, but you can do this. You can add underscores, you cannot add dashes. You cannot add pluses, because that can be obviously kind of confusing. Any arithmetic operator, you cannot add. You can't do parentheses, because it'll mistake that for a function, if that's what it looks like. You can't do carets. And I'm sure with experimentation, you'll quickly be able to figure out what you can and cannot use. You cannot use that, for example. And usually it makes logical sense. So now that we have an idea of how we can name our variables, and I can make this literally as long as I want, except I can't have the semicolons. Say the semicolons I didn't put in. And then I can put this whole string of text into there. And I can, like I said, when I say you can name your variable anything, I mean you can name your variable anything with small restrictions. And this will print out 12, as I've already told you. I'm just proving that you can literally name your variable anything. It doesn't have to be a real word. Yeah. And then after that, you have two options. Are you going to set it equal to something, or are you just going to declare it, or are you going to access its constructor? And I'll talk about constructors later. I say that a lot during this tutorial. If you're going to access its constructor, you're going to do that. It'll assign this value to this variable. That's absolutely not important right now. Actually, forget I said that. That'll just confuse you thinking about it. If you choose not to set it equal to it, unlike in Java, you can just do int variable name and then a semicolon at the end without assigning it a single value. And if we run this, depending on your computer, it will say uninitialized local variable. Pretty much what it's saying is you have to call the constructor. Basically, what I'm doing here is not a valid way to declare this variable, at least in the new version of C++. It used to be fine, but it's actually considered undefined functionality, an uninitialized variable. Alright, so, but what I can do is I can do variable name equals 1. And now if I run this, it works perfectly fine. So you're going to have to initialize your variable at one point using an equals operation. So now that we have a good idea of how to use ints, and like I said, I'll just go over one more thing, 12.12. If I run this, just take a guess at what's going to happen. Is it going to round up? Is it going to round down? How's it going to work? It rounded down to 12. And therefore we can assume that if I put it at 5.2, it'll likely round up. I was wrong. Maybe 8.2? Yes, I actually didn't know this before, so I'm learning something too. Apparently it floors the values. Like, I can probably have this at 0.99, and it'll still round to 12. Yeah, that's very interesting. Apparently it takes the value here that's equal to the integer, and then sets it to the closest whole, well, not to the closest whole number value, the lowest whole number value. Very interesting. So, I guess I'm learning something too. But let's say I want to keep this variable and have it actually print out how it's supposed to onto the screen. Well, I have two options. I have float or double. For now, let's just stick with double because it's more precise. Boom. 12.99 is printed onto the screen. Alright? And obviously, I can have many decimal places. I don't know if it'll be able to handle all of those, but yeah. And sometimes it just doesn't print them all out. Sometimes it actually equals a certain value, but it prints out a different one with less precision, a rounded variable. So that's always a problem. But I do not know how many decimal places it can process, but it's probably closer to, yeah, that's a good number, about 8 of them. That would make sense. And for a floating point, I'm assuming it's either a double can do 16 and a float can do 8, or a double can do 8 and a float can do 4. I'm honestly not sure, but that's not super important. If you want high precision, just use doubles, and if you want less precision but more memory, less memory intensive, use a float. So I'm glad we covered that. And then finally, I think the last thing we really need to cover is a char. Char character equals. Use the single quotes. If you use the double quotes, it will not work. We're going to have to put this. If you put double quotes in, what will actually happen is it cannot cast this to a char. And this is an invalid, well, actually that is a valid conversion. If I run this, prints out 0, because it's converting it to the ASCII value. So it's better, don't bother casting it to a char, or it won't work. You're going to just single quote the character and then end the quote. And this will print out A. And it does. So maybe I should cover, I keep talking about ASCII values, but I'm not telling you what exactly it is and how exactly it works. But before we cover that, what I'm going to do is I'll teach you a little bit about integer variable arithmetic. This is pretty important. So int number equals 12. Int number 2 is equal to, let's set it to 24. So let's say I want to do some arithmetic with these numbers. I want to somehow add a value to number 2 and I want to subtract 24. Value to add 5 to, value to subtract 4 from. Alright? How would I go about doing this? How am I going to go about doing this? So it turns out there's actually 3 ways of doing it. I can do number equals number minus 1. And keep in mind, this is not, or actually minus 5. This is not comparing these two values. This is setting the value of number equal to the original value of number minus whatever number's on this side. So, does that make sense? I'm trying to, let's do int number 3, and then it'll print out number 3. Should print out 12 minus 5, which is 7. Right? So this is method number 1, actually the least recommended way. The other option you can do is minus equals 5, and this will basically say, well, number minus equals 5. And then int number 3 equals number. Basically this is saying, alright, I'm going to set the value of number equal to the value of number minus 5, but it's just a compiler shortcut. Basically you don't have to write number equals number minus 5. So you're basically taking a shortcut. And then for this situation, when this is the least recommended way I have for decrementing variables, you have the option to increment or decrement your variables by 1, all by doing minus minus, or obviously plus plus. That will work to increment it, but minus minus will do that, and if we want to subtract 5, well, we gotta do this 5 times, right? So this will also print out the same value. In this case, I absolutely do not recommend that. Use minus equals or equals that minus that. So now we're going to do a bit more arithmetic, and I'm going to show you something slightly cooler. I'm going to set number 3 equal to the value of number 2 minus number. Basically, it'll take the value of number 2, which is 24, and then subtract it by the value of number. So it'll basically substitute 12 and 24, which would equal 12 when we print it out. So if I run this, it prints out 12. But if I put in number 2 minus number, we run this, it'll actually output the same value, 12. And we can switch around the order, and this will actually be the negative 12. I'm just trying to demonstrate that it can do negatives. Alright, so now we've covered basic, and you can do this all with integers, floats, doubles, longs, shorts. There's two other variables that I haven't yet talked about, Booleans, and I haven't really gone into enough detail about chars. So let's delete this and create a Boolean. Bool. In Java, it's written Boolean, but in C++, all you need is bool. O1 is equal to, or actually, I don't even know what I'm doing with this, but logic there equals false. You can set booleans equal to either true or false. They're basically either 1 or 0. So basically the easiest type of value for the computer to process. Basically, it's super efficient. So if I print out logic, it'll print out 0, because 0 is equal to false, right? And then 1 is equal to true. And then, so it's pretty straightforward Booleans, and this will print out 1. And there are a lot of cool if statement things in for loop and while loop things that you can do with Booleans, and we'll cover that later. But now you have a basic idea of how Booleans work and what they can be used for. Very basic, and we'll get to it later. Alright, and that brings us to more on ASCII values. So I'm going to start off by creating a char. Number is equal to 9. Now let's print out number. Let's say I want to somehow convert this value into a integer value. It's saved as a char. Let me just paint you a small scenario. You're loading information from a file, and when you're loading information from a file, it can only be loaded as a string. So then you narrow out this one number from that string, getting a char at whatever index, and it ends up equaling 9. But you need this char as an actual integer. You need int number val is equal to int number. You need somehow this char value to be converted into 9. If we do a standard cast using the parentheses, this will just cast it to its ASCII value. And that, whoops, I meant to put number val. This will just convert it to its ASCII value. It won't convert it to its actual value, which is 57. Totally not what we want. And this is very useful. I mean, this is something that I barely knew how to do for a very long time, but honestly, ever since I learned, it's been extremely useful. You're going to want to take the ASCII value for 0 minus number. 0 minus number. And that should convert it into an int properly. There we go. But you're going to need number minus 0. Alrighty then, this should work properly. Now, and this is actually an integer value, so I can do number value plus plus, incremented by 1, and then it'll be equal to 10. So what's actually happening here is the ASCII value for number subtracted by the ASCII value for 0 casted to an integer actually equals the integer value that you're looking for. It's just a very nice trick that ASCII characters were built in with, and it's extremely useful, and you're going to use it a lot when you actually begin programming big apps. So I definitely thought that would be extremely useful to show you. Just remember, char value minus the ASCII value for 0 returns the actual value. And it's because it's written like this. 0, in ASCII, this might be assigned to a value, but the one right after it is going to be assigned. This is going to be assigned like this. And then if you take, and it's all linear. So the distance between this char in ASCII and this char in ASCII is going to be 3, right? These 1, 2, 3. I'm trying to explain this in a way that actually makes sense. If I take the ASCII value for 3 let's say the ASCII value for 3 is 356. And then 0 would essentially have to be 3 away from it, so it would be 353. And it's not, or I mean 453. It's not, but essentially what it's saying, turn this into an integer. It takes 456 because that's the ASCII value. Now take the integer for this, which is 453, and there you go, that's the distance, and that returns 3. So this minus that is equal to the actual integer value. Super useful stuff, and you should definitely know how it works and how to do it. Now, I think I covered everything I needed to in this tutorial. I definitely hope you learned. Leave any comments or questions in the comment section, and be sure to subscribe, and I'll see you all next time.